Assalamu alaikum. Welcome to our comprehensive Ruby tutorial. My name is Muayyad Al-Hijji and my teammates Basil Al-Nasr and Ali Makki. We will help you start with Ruby. First of all, what is Ruby? Ruby is a dynamic open source programming language with a focus on simplicity and productivity. It has an easy syntax that is natural to read and easy to write. Ruby is widely used for web applications. Its philosophy revolves around making programming enjoyable and productive. Now, let us move to the installation procedure. For Windows, you can just head to rubyinstaller.org and you will find the download button over here. You can just click it and it will start automatically downloading. For Linux, you can use the command sudo apt get install and it will install the Ruby language. For macOS, it comes pre-installed, but you can update it to the latest version using the command brew install Ruby. Since I am using Mac, let's just update it. As you can see, I have the latest version up to date. Now, after installing Ruby, you might want to set up an IDE to write your Ruby scripts. There are different IDEs that you can use like RubyMine, Visual Studio Code, or Sublime Text. And in this tutorial, we are going to start with Visual Studio Code. How can we install Visual Studio Code? You can just head up to Google and write install VS Code. As you can see, downloading Visual Studio Code for Mac, Linux, and Windows. If you are Windows, you can install it from here. If you are Mac, if you are Linux, from here. If you're Mac, from here. So I'm gonna go with Mac, and it will be automatically downloaded. Just click it. And as we can see here, we have Visual Studio Code. Let's move it to the applications. Now let's open it. Now let's open a folder. You can choose any folder you want to place your Ruby file on it. I'm going to put it in the documents. I created the Ruby folder. I'll just open it. Then I'll create a file. Let's call it ruby.rb. .rb, that means the extension of the file is Ruby. And here we can just start writing our scripts. Now, let's get to know the data types in Ruby. We have integer, where you can represent a whole number, example 1, 2, or 100, or 1,000, or any number. The second, we have float, where we can represent a decimal numbers like 1.5, 2.9, and so on. Third, we have string, like name and city. Fourth, we have boolean, where you can represent true or false values. And the last one is called null. This means it has no value. Now, let's try them into our IDE. Let's say for the integer, let's say age is equal to 25. We didn't say that is integer like the other programming languages. Ruby is a dynamically typed language, which means that the type of a variable is determined automatically. So once we write age is equal to 25, it will be assigned automatically to be integer. So we can just print it. The command for printing is called puts. Puts age. Let's run our document, which is Ruby dot RB. Okay, I didn't save it, just save, run it again. As we can see, we will have the output, which is age, which is equal to 25. What about float? We can say, for example, temperature is equal to 36.5. And let's print the temperature. Puts temperature and save, run. As we can see, it's 36.5. Now let's try the string. Let's say name is equal to Muayyad. But in the string, we need to put around it a quotation mark. That's how we represent the string. So let's print it. Puts name, save, and run. As we can see, Muayyad, it's printed. Now let's move to the next one, which is Boolean. Boolean, let's say, is active is equal to true. Or inactive is equal to false. Now let's print them. Save and run. As we can see, true and false values. The last one, which is nil, let's see advantages is equal to nil. Let's print it. Save, run. As we can see, we have nothing printed, and it is nil. It has no values. That's how we can assign a variable and a value into our program. So now let's move in to try to do some arithmetic calculations. Let's assign a variable called a, and let's make it is equal to 8. And then let's assign another variable, which is b, and let's make it equal to 2. I want to get the sum of the two numbers, which is a plus b, and I want to get the difference and the product and the quotient. So let's try it. We can simply assign a variable called result sum, result sum, and make it equal to a plus b. Then let's try to print it. Put result sum, save it, run it. As we can see, we got 10. 8 plus 2 is equal to 10. That's correct. Now, let's try the product. Let's say result product is equal to a times p. This is the symbol of multiplication. And now let's print the result. Result product. Save. Let's run it. 8 times 2 is equal to 16. That's correct. Now let's calculate the difference. Let's say result of the difference is equal to a minus b, and this, let's print the result. Save it, just run. As we can see, 8 minus 2 will be equal to 6. Now, let's find the quotient. Quotient is equal to a divided by b. And now let's print the result. Save, print it, and we got 4, which is 8 divided by 2 is equal to 4. Now we have another one called the remainder. Result of the remainder is equal to a, this is the symbol of the remainder, b. Now let's print the result. The remainder, save, just run the program, and we got 0. 8, the remainder of 8 divided by 2 is equal to 0. That's correct. Also, we can just change it to make it float. It does not have to be an integer. And let's run it again. As we can see, all the values have been changed as a float. What about if we put one integer and the other one is a float? As we can see, the result, all of them will be float. Now, what if I have a number, like let's just say C, or let's just say X is equal to 2, and I want to convert it to a floating point number. I can just simply type X dot 2 F, and that will make it to be float. Let's print it. As we can see here, X now is a float. It's not 2, it's 2.0, which means it is float. What if I have a string like X is equal to 2 as a string? We can also change it to float using the same command. Let's try it. As we can see, it changed to 2 as a floating point number. Now, what if I have like ABC, a text, and I try to convert it into float? Let's try it. As we can see, the result is 0. By default, if you convert a text like ABC to a float or to an integer, by default it will be 0. So let's try it to change it to integer. We can just simply write I and save it. Run it again. As we can see, it is 0. What if we have 10 and we want to convert it to an integer? Just run it. As we can see, it is an integer now. What if we have numbers like 2 and we want to convert it to a string? We can just simply replace I with S. This will convert X to a string. We can just run it. Now it's converted to a string. Now let us move to our next topic. We learned how we can store values simply by assigning them to a variable. But each variable can hold only one value. Like X here can only hold 2. What if we have a lot of data? We have a lot of numbers. Here the rule of array comes. To store a lot of data and control it and access the information easily. How can we create arrays? Let's try to create arrays. Let's say we have sports and we want to write the sports names like basketball, baseball, golf, football, and a lot of sports. We do not want to make variable for each sport. We can just make one array for all the sports. We just can name it sports is equal to array, and now here we can list our sports. Let's say tennis, and the other value we will separate them by comma. Now let's put the other value, which is basketball. Let's add a third value, which is, let's say, golf. Now, if I want to print all of these values, I can just simply print it sports. Let's save. Let's try it now. As we can see here, now we printed tennis, basketball, and golf at once, and we stored it in only one variable. Now, what if I want to put a string or a number, like let's say 1, or a boolean, let's say true? Will it work? Let's try it. Yes, with Ruby, arrays can store any value. Now let's get back to our array. Now, what if I want to access a specific element in my array? Let's say I want only to print tennis. I can simply write the number of index of the specified element that I want to access. In arrays, we have index for each element. For the first element, it starts with 0. For the second one, 1. For the third one, 2. And so on. Now, let's try it. Let's print sports 0. Let's save it, run it. As we can see, we got only tennis. What if we put here 2? We will get golf. Let's save it, run it. As we can see, we get golf. What if we want to access the last value, like golf, but I do not, maybe I have 1,000 or 100 value? How can I start from the end? I can just simply write -1, and this will give me the last element in our array. Let's try it, save and run. As we can see, you get golf. What if we put -2 over here? You will get the second last element. Let's save it, run it again. As we can see, we get basketball, and so on. -3 will give us tennis. But what if I want to select a specific range? For example, I want to select tennis and basketball, but I do not want to select golf. I can just simply write the range from 0 to 2. But here 2 is not included with us, so it will print index 0, index 1, and it will stop on index 2. It will not print it. It will not will be selected. So Let's save it and run it. As we can see, we have tennis, we have basketball, but we do not have golf. Now, what if we want to change a value in our array? Simply, we can reassign it. For example, let's change tennis to hockey. Let's say sports index 0 is equal to hockey. Okay. Now, let's print index 0. As we can see, it is hockey now. What if I want to add a new element to the array? I want to add tennis back. I can simply use push, like sports dot push, and right here tennis. Now let's print the whole array, save it, run it. As we can see here, now we have hockey as we replaced tennis by hockey, and then we pushed tennis as a new element to the array. It will come to the last. And we print it, as we can see here, hockey, basketball, golf, and tennis. Now, what if I want to add it to the beginning of the array, like tennis here? I have push it, but it's at the end of the array. What if I want to add it to the beginning of the array? I can simply replace push with and shift. Let's save. Let's try it. As we can see, tennis has been added to the beginning of the array. As we have our array, it's hockey, basketball, then golf, and we have added the tennis at the beginning, as we can see the output here. What if I want to insert it in a specific place? Let's say to index 1. We can just simply use insert. Insert. And we'll provide the index, which is 1, as we said, and we'll provide the object, which is tennis. Now let's save. Let's print it. As we can see, now index 0 is hockey, index 1 is tennis. What about basketball and golf? It has been moved 1 index forward. Basketball now index 2, and golf now index 3. Now, what if I want to delete an element from the array? We can use pop, like sports dot pop, and then let's print our array. Save it, run it. Let's print between them a separation line. Save it, run it. As we can see here, here is our array before deleting, and here is after. What Bob does, it has deleted the last element. Where is here? Golf. Golf has been deleted from our array because of Bob. Now, what if I want to delete the first element? I can simply use shift. Let's save it, run it again. As we can see here, hockey now has been deleted. What if I want to delete a specific index? I can simply use sports, delete, and then add and provide the number of the index. Let's say index 1, which is, in case of us, we have tennis here. Let's save, print it. As we can see here, tennis has been deleted. Now, let us learn a new topic, which is called pointers and reference types. In Ruby, unlike languages such as C or C++, there is no explicit use of pointers. Instead, Ruby handles all variables as references to objects. This simplifies memory management and avoids the complexities associated with direct memory access, making the language safer and more accessible to beginners and advanced programmers alike. Understanding references in Ruby. In Ruby, when you assign a variable, you are actually assigning a reference to an object, not the object itself. This means that if you assign one variable to another, both variables point to the same objects. Let's try it. Let's say original array. Original is equal to, let's give it numbers like 1, 2, and 3. And let's make a copy. Let's say copy is equal to original. Now, what will happen if I say copy dot push and the object is 4, and now I want to print the original array. Let's save it. Now let's run our program. As we can see here, original has been changed. Number 4 has been added to the original. It's only a reference. As we can see here, when we changed a copy, the original also has been changed. Now, behavior with immutable objects. Ruby simply types, such as integers and simples, are immutable. This means that every unique value is stored only once in memory, and any reference to that value points to the same object. Let's have another example. Let's say we have A is equal to 100, and let's say B is equal to 100. And let's see the ID of object A, and let's see the ID of object B. Let's print them. Put A dot object ID and B, both B dot object ID. Now let's save it, let's run it. As we can see, both of them has the same ID. This means both A and B reference to the same object in memory. To create a separate copy of an object in Ruby, you can use clone or top method. This is particularly useful when you want to modify a copy without affecting the original object. Now, let's try it. Let's say we have array1 is equal to 1, 2, 3. And let's say we have array2 is equal to array1 dot dop. This creates a copy, a shallow copy of array1. Now, if I typed array2 dot push, then on per 4, and I printed the arrays, what's array1, then what's array2, what will happen? Let's separate them here. Puts dash. Save it. Let's run it again. As we can see, the first array has not been changed, but the second array has changed. That was what I'm going to present to you today. I'll leave you to continue with my friends.
بسم الله الرحمن الرحيم. السلام عليكم جميعا. Hello everybody. So I'll complete the presentation by talking about mainly the control abstraction part in Ruby language. So mainly we are going to talk about four main points, or these are the outlines. So the logical expressions, the conditional statements, the repetitions, loops, and so on. And the last thing is the functions and procedures. So let's get started with the logical expressions. So simply, the logical expressions are the operators that we can use the operators to express some logical expressions that we could use then in the conditional statements and so on. So mainly we have three operators in the logical expression context, which are the basic operators in every language: and, or, and not. So the and will be true. So let's go to the code. So we can just enter here the interactive Ruby, which is in the middle. Just run this command, IRB, in the Linux system, and you can refer to the other systems command. So this interactivity shell, we can demonstrate some concepts with the logical expression. So so at the end, operator will be true if both operands are true, as you can see. So we have the true result. And also there is the equivalent operator, which is the double and sign. So you can, for example, use the double and sign and it will give you the same result. The only difference between them is just the precedence or the priority in the execution, the command. We have also the or. So for example, or false or true will give you true, because one of the operand is true. And the not operator, which is just converts to the opposite Boolean value. You can also use this this sign, which will make the same thing with that thing, with the not operator. So simply this is the code for the entire truth table for these commands. So we can just run this script to see the results. Ruby, the file called logical expressions. And as you can see, the not operator in the first 2 lines, it just converts from false to true, from true to false, and the or true table. And the last thing is the and truth table. And also we have just the operator precedence. So the precedence of the operators, actually it's known that the and is the higher precedence, and the not is the first thing you apply, and after that you go to the and the last thing is the or, which is the weakest operator here in the logical context. So as you can see here, in this line of the code, or this actually line of code, you have true or true and false. So the and will be evaluated first. So this will evaluate to false, since one of the operands are false, and then you will OR the false result with a true result. So true or something will give you true, and as you can see, we have got the true value. And last things, I want just to cover the equivalent function, or equal function. So as you can see, or as you know, in the Ruby, everything is just what? Objects, right? So if you go and try to make the comparison, the naive comparison, like A equals A, this will give you true, because you are comparing the values, which is actually what we need here. But sometimes you need to compare just to make sure that are these the same object or not. You don't target the values of that comparison, but you are targeting the object reference in the memory. So let's say that we have, for example, the same A and dot equal A. Now the result will be false, as you can see. So from the previous command, they give us the true, but here it gives us false. Why? Because here the comparison between the values of the operands. However, in this context, it is comparing the object reference in the memory. So as you can see from the code we have just run, the last part we are just do what we have done in the interactive shell. So comparing the values in the by the equal method, it is comparing the object. Are they the same objects or not? However, comparing them by the equal operator, or whatever operators are, it's just comparing the values. And as you know, there are multiple other operators in the comparison context, like the greater and less than equal, not equal, and so on. And they are always the same usage. You have two operands and you do your comparison. Now let's move to the conditional statements. After we have done with the logical expressions, now let's use the logical expressions in the conditional statements. So simply, in the conditional statements, you have this basic structure. So the if, which is keyword, and then you have your condition. You can use the logical expressions that we have just explained, and then here the code block that will run if the condition is true. Also, you have another structure. If you have the base or default after, if the condition is false, it will run the else part. Also, you have, if you have multiple conditions, you can use the if else if with this syntax, which is will make first this condition, check it. If it's true, it will run the code here, and if it's not, it will check the second condition, and so on until it gets to the last part, which is the else part. So let's see some examples in code here. So for example, you could say that for example, put whatever high if, let's say for example, 5 less than 3, and this is false, so it should return null, which is the other part. But now when we say that, let's say make it a true condition, it should print the, so P stands for put, which is the print function, nothing rather than that. So this is like a syntax, a sugar syntax, which is the main thing that the main thing with this syntax. However, instead of doing it with multiple lines, if you have just one statement like this, you can put it in the same line and put the code block here and the condition on the right side. So let's run this code and see some explanation. Ruby, the file called conditionals. So as you can see here, on the first thing, we have defined the number to be equal to 5, and we did a comparison. We asked, is the 5 between 1 and 10, which is true, and that's why the output here is the first code block, which is the number is between 1 and 10. And if it was false, it will enter this part, or it will check the condition. If it's between this interval, it will enter this part. And the last thing, if it's not in this part, neither in that part, it will enter the last part. So that was the if else part. Now let's move to the unless operator, which is another operator, or let's say another feature in the conditional statements. So the unless statement is nothing but is equal to if not. It will run the code block if the condition is wrong. So it's the opposite of if. So as you can see, I wrote here between parentheses if not. So you could do the same thing with if statement. However, you need to put the not keyword in the condition part. If you just want a shorter syntax, or maybe more elegant, or maybe more cleaner in your code, you can use the unless. So for example, let's say that put here true if what, unless, let's say unless 10 greater than or less than 1. So as you can see here, the condition is wrong, right? Since the 10 is the greater than 1, it is not less than. However, the code runs, or the block, the code enters the block. Why? Because it is the same thing as saying if not. So this is, they are equivalent. Instead of saying if not, then the condition, you can just make it short and say unless. So unless is the same as if not. Okay, so this is second part of the conditional statements. And the last thing, we have the switch statement. If you have multiple conditions, it may be easier just to use the switch statement and then compare the values you have. So you have two modes, the make case and then put the value that you want to compare, and based on that value you can just put the conditions after one statement and put the code inside those parts. Or you can just make don't use the variable after the case, and just use the normal conditions or Boolean expressions after the one. And so let's run the code again, and as you can see, like here for example, in the switch statement, since the value is true, the first one, which is the value is true, got runs. Okay, and the second thing, like here the number is 7, so when we entered the case switch statements, we entered the one here, which is the number is greater than 5, which is the third one. Okay, and the last thing, we have a shorter syntax also for if else statements, which is called ternary operator. So let's see this example. We want to ask this question, does this number even or odd? So let's use the modulo operator, equal 0. So if it is equal to 0, then we could say that it is even, right? And if not, it is then odd. So we want to print one of these statements. So sorry for that mistake, because we forgot the question mark after the condition. So as you can see now, we have, since the 10 is divisible by 2, then we returned the first outcome after the question mark or after the condition. And if the number, let's say, change it to make it something like 11, Now it is not even, it's not divisible. Since this part is false in this statement, so we will go to the part after the colon, which is odd. As you can see here in the example, if we print the last one, so we have the age is 18, and then we asked that if the age is greater than or equal to 18, then the message should be you are an adult. But if it's not, you will be like a minor. So, and the output was you are an adult, since we have 18 greater than or equal to 18 is true. So we returned the first part of the ternary operator. And this ternary operator could be used if you have simple conditions. You could write them in just single line instead of multiple lines with if-else statement. Now, after we have finished with both logical expressions and conditional statements, let's move to the repetition part, which we will talk about mainly loops and iterators. So the loops is when you are repeating your code blocks for many times until some condition it happens, or be false or successful, depends on the statement that you will use. So for example, let's see some code. So we have first the while loop, which is will run until this condition being false. So since it is true, it will run until that being false. So let's run this code. Ropey dot the file calls loops. So as you can see, we have run this statement 5 times since we start from 1, and the condition was until this being more than 5. If it's being more than 5, then this condition will be false and we will stop. So let's move to the another loop type, which called until. And until, it is like unless with the if statement. So unless was the opposite of a statement, and also the while, or let's say until is the opposite of while. So until this condition is wrong, then execute the block, so that at the end we need to make this condition, or we want to reach some condition to be true, so we can exit the loop. So let's run this code here. I'll say save it, for example, first, and then let's run it. So as you can see, we didn't stop. This is the until while not. We didn't stop until this condition was true. So since it is false, until we satisfy this condition to be true, we will still execute this loop. So this is the opposite one with the while loops. And we have also the for loops, which is common loops. So you will run your code for the known number of times. So for example, you can change here the borders to be like, for example, 10. So you know how many times you want to run. You don't have a condition, you just have a certain number of times you want to run. And last but not least, we have for each, which is if you have an iterator, something like the array, and you want to execute some operations on each one of its element, you will use something like for each loop. So for example, here we are iterating over the array and just printing the numbers. So if we change, for example, list to be whatever number, you will see that we got the same number. So we are iterating on this array, which is an iterator, general type of iterators objects, and we named the let's say the variable which in each iteration being named as a number, and we can then use it and embed it in this syntax string. And the last thing, we have another also iterator example, which is just taking like two variables, the items themselves and the index of the array, and adding the index to the number itself. So let's run it and see what will happen. So as you can see that the for example, the number 5 is have the index 4, so 5 plus 4 is equal to 9. And as you can see here from the output, it's just adding the index to the items inside this iterator. So this is simply the loops and iterators features in Ruby. And you have some keywords like break, if you want to break the loop when something happens inside the block. You have the next, which is maybe called continue in other languages like Python and so on. You have the redo, which when you want to redo that certain iteration, and you have the retry when you want to restart, or say start from the beginning of the loops and a kind of just rerun it from the beginning. So that was the repetition part, and the last part now we will talk about is the functions and the procedures. So simply, what are from the theoretical part, what are the difference between the functions and the procedures? Functions typically return a value when you want to do some operation, some computation maybe, and you want to get that value. You call that a function. But if you want just to do a certain operation without returning a certain value, then you call it a procedure. So now let's just see the syntax of the defining functions, or as they called in the Ruby methods. Since everything is a object in Ruby, object oriented, then we call the functions who are belonging to some classes a method. So the syntax is simply to use the diff keyword and then your method name, and then you hear the block of the method that you are writing, and just enclose it with the end keyword. Also, you can pass some parameters between just the parentheses simply, and then you can use this parameter as an argument. If you pass it, if you call it in your code, you will pass the argument, which is the explicit value, and it will be stored in this parameter. So let's do some practice with the functions, and I will copy this definition of an add function, a simple add function, to the interaction Ruby shell. So let me define this one, and now I have the definition of the add function. I will call it with different values. Let's see. So for example 5 and let's say 10. So we got the 15, and you can just put it as a in the string context. For example, so print sum of let's say for example 2 and 6, and then you could just use the syntax and call the function inside here. So 2 and 6, and you will have the result as you can see. Just let's maybe run it with a more clear syntax. Here put like a equal sign. So as you can see, you can just call this function with different arguments as you wish. So this is the function part. And the procedure, let's see this. For example, this is another function before getting into the procedures. So this is a function, however it's using the factorial behavior. So the factorial is when the function needs let's say ask or call itself again and again. Sorry for that confusing. I mean, the recursion part is that when the function calling itself again and again. However, the factorial, its definition actually needs to be implemented in one of the ways. You can implement it using the recursive way, because it's the definition of the factorial. It's the multiplication of that term until the factorial 0. Okay, so the nature of the definition of the factorial using recursive to be implemented, like in this function. So as you can see, here is the definition of the factorial of a given number. It is just the multiplication of that number down up to the 1. Okay, so we have here our function defined in the interaction shell. So let's just, for example, try to calculate some factorial. So the factorial of 1 is just a 1, factorial of 2 is 2, factorial of 3 will be 6, and the 4 will be 24, and the 5 will be 24 times 5, which is 120, and so on. So we can use the function and pass the argument we need just to do our computation, and the function will return that value. So now the procedures are just defined methods, but without returns values. So like here, this greeting method, you will pass it the name, and it will print hello with that name without returning some value. So here in the functions we use the return value, but here in the procedure we just doing some operations. So let's like print copy and paste this definition here, and then let's use a great function with different names. So let's, for example, use it with Badr. So there was a syntax error. It is greet, not geet. Okay. So as you can see, it prints it did its operation. However, the returned value is just nil because there is no return statement. Now, just for example, let's call it with another name, like maybe Ali, and so on. So you can pass it the arguments, and it will do the operations, but there is nothing to return. So that was the function and procedures part. So we have covered in this tutorial the logical expressions. We've gone with the operators and the truth tables, and we talked about the difference between the equal, for example, and the equal method, which look for the objects. We have looked for the conditional statements and the unless keywords, for example, which is the opposite of if. And we have also looked at the repetition and the while and until. They are just a kind of opposite of each other. And last thing, we just have talked about the procedures and functions. So this is the main parts in the control abstraction part or sector, I'll say, in this language. I hope it was useful. So just for enhancing your understanding, we will have a simple quiz about what we have just covered. So now let's just have some practice, multiple choice questions and true and false questions. So here we have both the variables, and then we are comparing those variables and cancelling out their value, the comparison value on the screen. So what's the output will be? I hope you guessed it correctly, because we are comparing the values, not the object, which is true here in this case. So this is a similar one, but with equal function that we have discussed. So as you can guess now, the output will be false, since we are comparing the objects and we are asking, are these objects are the same object? And in this case they are not, because they are two different definitions. Third question is about precedence operators and logical expressions. So what the value will be evaluated to? It will be evaluated to true. Why? Because the not true, which is the first thing will be evaluated, will be false, and then false or true is true. Another question about the iterators. So we have here an array, and then we are iterating over its number, and we are doing number plus 2. So we are adding 2 for each item. So what's the answer will be? C, as you can see, because we are adding 2 to each item. Now we have a question about functions. So here's a definition of the function, and then we are asking which definition is correct and which definition is wrong. So you may guess it. It is D. Both are defined well and will be correctly syntax, and this is because a feature in the Ruby language, you don't need to put the return statement at the end of the function block, because if it is a statement, it will be taken as the returned. If it's a value, if it's a valid value, it will be taken as the return value. So both are the same function actually, but with different syntax. And this question is about scoping. So we are defining a function, multifunction or mul function, and then we call it, and then it prints the value. So what's the answer will be? It will give an error. Why? Because the value here, it is inside the function definition. It's not in the scope of the outer. After we calling it, we cannot access the value variable. So it will give you an error. And that was the last question. Thank you for joining our tutorial, and I hope it was useful for you. I will leave you with my colleagues. Thank you for that. See you inshallah in next videos.
Okay, so I'm now going to talk about some advanced topics in Ruby. And first of all, we're going to talk about the programming paradigms supported by Ruby. So firstly, we have object-oriented programming. And so Ruby is a pure object-oriented programming, and everything is treated as an object. Even that methods are also treated as an object, as objects, for example, and they support standard object-oriented programming features such as encapsulation, inheritance, polymorphism, and it also encourages defining classes and objects to model real-world entities. And secondly, we have functional programming. So Ruby supports function programming features like first-class functions and high-order functions. So you can return functions from other functions and pass a function to another function and so on. And it also supports lambdas. And it's also emphasizes immutability and pure functions so that we have predictable outcomes. As for concurrency support, so firstly for normal thread-based concurrency, which is basically thread concurrency by the operating system. Ruby started supporting those native threads since version 1.9, which are supported by the OS, as I said. And secondly, we have fibers, which are basically user level threads, and there is also async IO, which is basically for network programming. We're also going to talk about some other Ruby features. So firstly, we have dynamic typing, which is basically that types are specified at runtime instead of compile time. There is also duck typing, which is basically that types are defined by the behavior of the class. Ruby also supports garbage collection, so memory automatic memory management through garbage collection instead of manual garbage collection. It also supports metaprogramming, which is basically being able to enable dynamic method and class definitions, and we're going to see this in the code demo. And there is also blocks and procs, basically elegant handling of code blocks and closures, which is important for programming in a functional way. Now going to go through the demo. This is the demo here. Firstly, for the object-oriented programming style, we have a class called animal here, and then in line 2 we have this line attribute accessor. This basically creates getters and setters for the name field, and this is where we initialize the class instance. And then here we have a method called speak, and right here we have we're creating an instance of the animal class called dog, and then here we run the speak method on the class instance, and we print the output. So we'll run it here, and as you can see, this is the output. And second, we'll move to functional programming. We have this very simple example. We have a function here called greet, and it returns an anonymous function which basically prints takes a name and returns this string. And here we assign the greet function to a variable, and then we call we create a function and call it, and we give it a name of world. And if we run it here, you'll be able to see the output hello world. Now we'll move to concurrency. This is an example of threads. Here we're creating 5 threads, and we're basically making each thread sleep for a random number of time between 0.1 and 1 second. and then after the thread finishes running, it will print thread I finished, and here we basically join each thread. And now I'll run it. And as you can see, five threads started running and they all finished. Now I'll move to the last part of the demo. Here we have the basic meta programming example. So firstly we have a dynamic greeter class, and it has a method for creating a dynamic method, which is called the create greeting method. And here we're creating two methods. The first one is hello, and the second one is goodbye. And then here we call the two methods. First call is with Alice, and the second one is with Bob. And we'll run it now. And as you can see, this is the output, as in the code example.